Hey everyone, so in this lecture we're going to be starting with permutations and combinations. This is going to be a very important topic to understand, so we'll go slow and I'll also try to explain things in the best way possible, right? So I'm going to start with the question first. I think this question would clear out what is permutation and what is a combination, right? Very easy topics to understand, but I think as we go across different problems and formulas, it gets tricky, right? But I think if your base is clear, I think even if you deal with the most complicated problem, it should be fine. Okay, so I ask you the question. Let's say there are 4 friends: Alice, Bob, Carol, and Dave, right? My first question is, how many ways can you pick a secretary, president, and a vice president, right? So let's just think about this, right? One idea is, let's say for the pres, it's asking how many ways can you pick a secretary, president, or VP. So my idea is maybe I can pick Alice as the president, Bob as the secretary, and Carol as the VP. Maybe I can pick Bob as the president, Alice as the secretary, and Dave as the VP, right? Let's just take a look at an example. So maybe pres equal Alice, VP equal Bob, and secretary equal Dave. Right? This is one of the ways that I can pick it. Okay. Now let me ask you. So let's say for the second case we pick up president equal Bob, VP equal Alice, and secretary equal. So let's say Dave says the secretary and we just interchange the positions of Alice and Bob. Okay. Now my question is, do you think these are 2 different ways, or do you think this is the same way? Like, do you think this is a different combination, or I should say, is this a different way of having the positions or not? The answer in this case would be yes, right? Think about this. Alice being the president, Bob being the vice president, and Dave being the secretary is different from the Bob being the president, Alice being the VP, and Dave being the secretary, right? Now, once again, let's say if I change and make Dave the president and make Bob the secretary, right? In that case, it would be another example. So it would be, I should say, another one of the ways to pick a secretary, president, and VP. So my idea is, think about this, right? In this case, the order matters. So the point is that if I interchange them, or if I change the arrangement, that matters, right? That would lead into a different way of picking up the secretary, president, and VP. And whenever the order matters, right, that's when we call it a permutation. So question 1, asking about permutation. So the idea is, the question is asking how many ways to pick a secretary, president, and VP. And I realized that, okay, if I pick Alice as the president, Bob as VP, Dave as secretary, that's fine, right? That's one of the ways. But if I interchange any of these values, if I change the order of it, then it would give me a different example. And since the order really matters in this question, hence it is a permutation question. Okay. Now let's take a look at the second question, which says how many ways to pick a committee of 3. Okay. So we need to pick a committee of 3, right? Let's just say I pick Alice, Dave, and Carol this time. Okay. Let's just say we pick all these 3 people. Let me ask you the question now, right? If I interchange them, if I move Carol to the beginning or Alice to this position, let's say we do Dave, Alice, Carol. Do you think interchanging these positions would make a difference? The answer would be no. Think about this, right? All you're doing is you're just being asked to how many ways to pick a committee of 3. So the idea is that if you interchange them within the committee, it doesn't matter, right? It would be different if I pick another person instead. So if I pick if I remove Dave and I pick Bob instead, or maybe if I removed Carol and I put Bob instead, that would be another way of picking the committee. But the idea is inside the committee, if I try to rearrange them, that wouldn't make sense. So can I say that order does not matter here? And since the order does not matter here, hence this question is about combination. So my way of explaining is kind of like very simple. What I'm trying to tell you guys is, whenever we are trying to see and whenever the question involves that the changing the order could result in a different way, right? That would mean that it's basically a permutation. Whenever in changing the order doesn't really make a difference, that's when we would say that it's a combination, right? In question number 1, if I change the secretary or the president or the VP, that's a different way, right? That's a different way of picking up these people. So that means the order matters, and hence I'm trying to find the permutation. And in this case, in question 2, it says how many ways to pick a committee. So the idea is I can either pick Alice, Bob, Carol, or maybe I can put Alice, Dave, Bob. But the point is, inside the committee, it doesn't matter if I arrange them over here and there, right? It wouldn't really make a difference. So since over here, the order does not matter, hence we say this is a question about the combination, right? So I hope that's kind of making sense. It's totally fine if it's kind of still blurry in your mind. We will take a look at examples and I'll move on to them. And then I think it will make a lot more sense, right? So now let's try to understand the permutations. Okay, everyone. Now let's take a look at the definition of a permutation, right? And we're going to relate it directly to question 1. So just like I said question 1 is actually asking us about a permutation. How many ways are there, right? And the point is that it's asking us to pick up a president, vice president, and a secretary, right? Now the problem is that I can pick Alice as the president, Bob as the VP, Carol as the secretary. But if I change it, if I let's say pick Bob as the VP and Carol as the president, that change in order actually matters, right? That results in a different way in itself. And whenever a different order, whenever the order changes the format or it matters, we say it's asking us a permutation, right? Okay. Now let's take a look at the definition and what's the formula for a permutation. It's basically a permutation is an ordered arrangement of objects, right? Ordered arrangement, this is a very important word, right? Meaning if I change the order, that would matter. That would result in a different way. Okay. So the formula is pretty much P and R equal n factorial divided by n minus R factorial, where n is the number of objects and R is how many you are picking. So let me just quickly try to explain the factorial first, right? So let's take a look at 5 factorial. Factorial is pretty much that you keep on multiplying until you reach 1. So 5 factorial would be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. And let's say you have 6 factorial, it would be 6 multiplied by 5 multiplied by 4, 3 multiplied by 2 multiplied by 1. 2 factorial would be 2 multiplied by 1. So n factorial in general would be n multiplied by n minus 1 multiplied by n minus 2. It keeps going until it reaches 1. Right, so I hope you understand what the factorial is. The formula is n factorial, where n is the number of objects. So in our case, the number of objects we have is 4 and R is how many you are picking. So we have 4 friends and we are picking 3 positions, right? So president, VP, and secretary. So let's just quickly solve this question. So n would be 4, R over here is actually 3. So this gives me 4 factorial divided by 4 minus 3 factorial, which is equal to 4 factorial by 1 factorial, right? So if you look at it, this is pretty much 4 multiplied by 3 multiplied by 2 multiplied by 1 divided by 1, which gives you 24. Okay, so whenever you see a permutation, all you have to do is that you need to use this formula and find the permutation, right? Now, how do you find a permutation? whenever you see some kind of a problem where changing the order would matter, that's where you're supposed to use a permutation, right? You don't even have to remember this formula, and I'll also try to logically explain what this means. Okay, so let's take a look at this question from a different perspective, right? Okay. You have 4 friends, and it's asking us how many ways are there to pick up a president, VP, and a secretary, right? Let's say I'm picking the president. I need to find out how many different ways are there, how many different possibilities are there. So the idea is that first thing, let's say 2 people can't be in the same position, like one person can't be in the same position. So I can't have Alice be the president and the VP for this question. Let's just consider that. So the idea is, let's say first I am picking up for the president position. Right now, I haven't picked up anything yet. Right, so if I'm picking for the president first, I have 4 people in the way. So that means there are 4 choices I have. Right? Let's say president is the first position that I'm choosing for. I have 4 people that I haven't selected any of them. So that means for the president, I would have 4 choices, right? Okay. Once I have picked the president, right, I would have 3 choices left. So when I go to VP, it would be 4 minus 1, which is equal to 3 choices, right? So let's just say that for the president, I had Alice, Bob, Carol, and Dave as options. Let's say I picked Alice as the president. That means for the VP, I would have Bob, Carol, and Dave as the options. So now let's say I pick Bob as the VP. So for the secretary, how many choices you would have? You would have 2 choices left. Okay. So now if I ask you the question, how many different possible ways are there? So it would simply be 4 multiplied by 3 multiplied by 2, which is equal to 24 different ways. And that's exactly the answer we found, right? This formula is just like a formal way of solving the problem, right? Or formal way of solving permutations. But you can also logically try to find out. So it's just that when I was choosing the president position, I had 4 choices. For the VP, I had 3. For the secretary, I had 2. Now I can rearrange them, right? Maybe I can pick a person for the secretary first, for the VP first, or maybe any of them, right? But the idea is that this formula would remain same. For the first position I pick, I would have 4 options. Once I pick one person, right, I would have 3 people left. And then for the last one, I would have 2 people left. So in total, I would have 24 ways that I can pick any person, right? And using the formula, it's pretty much P and R equal n factorial by n minus R factorial, right? So just a quick idea once again, permutation is somewhere when you see a question where the order would matter, right? Now you can solve it in 2 different ways. One is you can just directly use this formula, right? N factorial by n minus R. Or you can also logically just try to think about the problem itself, right? So this was a problem where you can logically think. But it is definitely true that when you go across like more complicated problems, it would be better if you just directly use the formula. Okay, so I hope you were able to understand this concept. Now let's try to understand combinations. Okay, everyone. Now let's try to understand what are combinations, right? So we're going to consider the second question. So in the second question, once again, we have 4 friends, Alice, Bob, Carol, Dave. The question is saying how many ways are there to pick a committee, right? So first, let me just try to quickly explain what a combination is, and then I'll try to explain why this involves a combination, right? Combination is an unordered selection of objects. So in this case, this is an unordered selection, right? Why? It's just simply asking to pick a committee, I should say, of 3. So let me try to think about this, right? If you pick a committee of Alice, Bob, Dave, you can, if you change the arrangement of them, right? Let's say you choose, say, Alice, Bob, Alice, Dave, or Dave, Bob, Alice. The point is, if I change their arrangement, right, it wouldn't really matter because we're just picking a committee of 3 people. But if you remember, when we were supposed to pick up the president, the vice president, and the secretary, in that case, changing their order really mattered because that means that now the president is somebody else, or maybe the secretary is Bob or the secretary is Dave. If you change the position, right, that meant it in a totally different way. In a committee, if I just rearrange them, it doesn't really make sense, right? Or it doesn't really matter too much. So that's why in this case, this is going to be a question about combination. So combination is an unordered selection of objects. So now let's try to understand how do we actually find the number of combinations, right? Or what's the answer to this question? Okay, so if you remember, P of nr, or I can say P of 4 comma 3 was 4 factorial by 1 factorial, right, which was equal to 24. So when the order mattered, we had 24 ways in total. But now the question is that the order does not matter, right? So I can have Alice, Bob, and Dave in the same direction. If I interchange it to Bob, Alice, Dave, or Dave, Bob, Alice, it wouldn't really matter. So I'm supposed to pick 3 people. So let's just see for these 3 people how many different ways we can arrange them. So Alice, Bob, Dave is 1, Bob, Alice, Dave is 2, Dave, Bob, Alice is 3. We can have Dave, Alice, Bob, and you can have Alice, Dave, Bob. Yeah, you can have Alice, Dave, Bob, and one final would be Bob, Dave, Alice. Okay, so if you count it, there are total of 6 ways. So in these 24 times that we counted, right, we counted 6 times extra. So what we need to do is for the combination, or we need to find the number of combinations in this case, or how many ways to pick a committee. Since there are 6 ways that we have actually extra added, right, we would have to divide this 24 by 6, and that would give us 4 ways to pick committee. Okay. Try to pause the video and just try to think about if you understand this question or not, right? I'll just try to quickly explain it one more time. Okay, so the idea is, in the permutations, if you remember, right, we were supposed to pick up the president, the vice president, and the secretary. Now the idea was, if I interchange the position, if I make Dave the president or if I make Alice the president, every single time I change their order, that would be a different way, right? So that would count as 1. In this case, we're not picking a president, a VP, and a secretary. We're picking a committee of 3 people. So once we pick these 3 people, if we change their order inside the committee, it wouldn't really matter. So the problem is, now I have the count 24, and every group of 3 people that you pick, right? 3 people can be arranged in how many ways? If you think about 3 people, right, they can be arranged in 3 multiplied by 2 ways, which is basically equal to 6 ways. Think about this, right? I have 3 spots. First spot, I can put 3 people. Next spot, I have 2 options left. Final spot, I would have 1 option left. So it would be 6 ways. So the idea was 24 was when you also involve the order. Now the order does not matter, so getting rid of it is why we divide it by 6, right? And that's exactly how this formula is made. So according to the formula, C of nr is basically n factorial divided by r factorial multiplied by n minus r factorial, right? N is the number of objects, r is how many you are picking. So let's just try to solve this question using this formula now. It gives us 4 factorial by 3 factorial by multiplied by 1 factorial. So it gives us 4 factorial by 3 factorial, which gives us 4 multiplied by 3 multiplied by 2 multiplied by 1 by 3 multiplied by 2. So this gives you 4 ways. Yeah, it's kind of pretty logical to understand once again. Now, if you still have kind of a doubt in understanding this, I would say try to think a bit about it from a logical perspective, right? The point was, in combinations, we need to get rid of, we don't worry about the order. So if we change that order multiple times, it would be counted as the same thing. So we had to reduce that extra count that we did. And that's why I had to divide by this 6 value, right? Because if you pick 3 people, in the permutations, those 3 people, we had to add a 6 for them because they can be arranged in 6 different ways. So if I picked Alice, Bob, Carol, they can be arranged in 6 ways. If I pick Bob, Carol, Dave, they can be arranged in 6 ways. Same way, I can pick any 3 combination of them, they can be arranged in 6 ways, and that's why the count was 24, which is 6 plus 6 plus 6 plus 6, right? Okay, but in this case, we don't care about the order when the committee has been made. That's why we had to divide it by the value of 6, right? I'm sorry if I'm explaining it multiple times. It's just that I'm trying to make sure that everybody just understands what I'm trying to do. Okay, so I hope you were able to understand the combinations part. Now, let's just try to quickly understand when you're supposed to use permutations and when you are supposed to use combinations. Okay, everyone. So I'm just going to give like a final overview of permutation and combination using this very important question, right? So the idea is very simple. If I rearrange the item, do I get a different output or not? This is the question that you usually ask yourself if you're approaching a permutation or a combination question, right? So if I rearrange it, do I get a different outcome? If it is yes, if your answer is yes, then it is going to be a permutation. And if your answer is no, in that case, it would be a combination, right? So a few examples would be, let's say you're rearranging in gold, silver, bronze medals, right? So let's say who won the medal, or let's say from team of 10 people who won the gold, bronze, or silver. In that case, think about this, right? If you rearrange it, then that would be different, because if you change who won the silver medal or who won the gold medal, that would result in a different combination. So that's why it would be a permutation, right? Okay. Team members, if you rearrange the team members, that would be the same thing. That's why it's a combination. And for the last one, password, right? So think about if you arrange the letters of a password, that would result in a different password. So that's why it's going to be a permutation in this case. Okay, so I hope you were able to understand permutations and combinations. Now I'll be giving a bunch of questions for you guys to solve. Okay, everyone, I've given these questions on the board, so try to pause the video and solve them. Okay, so first of all, I've given this point over here, right? First, figure out if it is a permutation or a combination. So the idea is you need to figure out if the order matters or not. If the order matters, it's going to be a permutation. If it does not, it's a combination, right? So question 1, a club of 12 picks a captain and a vice captain. So how many ways are there? So think about this, right? Now, can you interchange a captain or a vice captain? And do you think the order would matter? And the answer would be yes, right? So let's say if I have John and Dave, if I make John the captain and Dave the vice captain, and if I change it, if I make Dave the captain and John the vice captain, these are two different things, right? So in this case, I know the order matters, and hence it's going to be it is a permutation. So what's going to be the answer? It's pretty much P of n comma R. N is the number of objects I have. So in this case, that's 12. R is how many I'm picking. So this would be P. I can just write it over here, which would be P 12 comma 2, which is going to be 12 factorial by 10 factorial, which is 12 multiplied by 11. Okay. Next one, a club of 12 picks 2 members for a trip. So how many ways are there? Okay. So now think about this, right? Let's say I pick John and Dave once again. If I rearrange them, if I pick John and Dave, or if I pick Dave and John, it's the same thing. That means rearranging them doesn't really matter, right? Order does not matter in this case. So hence it would be a combination, and the formula would be 12 2. So it's pretty much n factorial by r factorial, n minus r factorial, right? Which would be 12 factorial by 2 factorial, 10 factorial. Okay. Final question is, how many 4-letter words are possible from alphabets? Okay. So once again, let's just think about this, right? If I pick A, B, C, D, do you think this is the same as B, A, C, D? And the answer is no, right? So hence again, in this question, you are supposed to make a permutation, right? So it's going to be a P, n in this case would be 26. So I have 26 values. And how many I'm picking? I'm picking 4 letters, right? So that would be 4. So the answer is 26 factorial by 4 factorial. Okay, so I hope you were able to understand this video. Let me know if you guys have any feedback, and subscribe to my channel if you feel like that I'm teaching good. And if you have any kind of a feedback, even if it's like genuine criticism, like I'm always looking for feedback or any help that you guys can give me as much as possible, right? Okay, that's pretty much it for this lecture, and I'll see you guys in the next video.